On this channel, we provide useful programming information with practical code examples. This time, it's about closures in TypeScript. We explain the details of closures, their relation to memory leaks, and examples of their applications with code. Enabling subtitles will make the code descriptions easier to understand. Closure refers to the ability to retain references to the scope, environment, in which a function was defined, even if the function is called outside that scope. Below, closures will be explained including type annotations. Simply put, a closure combines a function and the variable environment where the function was defined, allowing access to that environment when the function is called. In TypeScript, when a function is defined within another function, it becomes evident that the inner function can access variables of the outer function. Here is a basic example of a closure with type annotations. Outer function returns the inner function, inner function. Inner function displays the value of the outer function's variable, outer variable. Below is an example of a closure with type annotations for encapsulating data. The createCounter function returns a function that returns a value of type number. The variable count is defined as a number type and is manipulated within the closure. Closures are useful when creating higher-order functions. Here, a higher-order function is a function that takes another function as an argument or returns a function as a result. Below is an example of a higher-order function with clear type annotations. CreateMultiplier is a higher-order function that creates a function to multiply by the number it receives as an argument. The inner multiplication function also takes a number and returns the result of the multiplication as a number. Let's also look at an example of implementing a range-based counter as a closure. The rangeCounter function returns a function that returns either a number or a string. In the internal function, if count exceeds max, it returns a string type message. Otherwise, it returns a number type. Closures can retain variables from an external scope, which may sometimes cause memory leaks. Unnecessary closures need to be explicitly released from memory. In this code, the large array created inside createLeak is supposed to be released when it goes out of scope, but it isn't because the closure captures large array. As long as leaky function exists, This unnecessary memory will continue to be retained. When an object or variable is no longer needed, setting its reference to null allows the garbage collector to detect it and release the memory. When creating closures inside a loop, there may be issues referring to the same variable. The following example shows a case where the variable I, declared with var, does not behave correctly. This code does not yield the desired result because I refers to the value 3 at the end of the loop. To fix this, either use let to separate the scope or use an immediately invoked function. By using let, the scope of I is separated for each loop iteration, yielding the expected results. In TypeScript, closures can lead to safer and more predictable code by leveraging the type system. Proper use of closures allows for data encapsulation and flexible design of higher-order functions. Additionally, care must be taken with memory management and unintended scope references when using closures. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. If you'd like to enjoy more content, please subscribe to the channel.